So we need to put this one correct. So I don't know if this one was, oh, it's 1.22, so it's the default value. But if you use CFSR, it has to be changed 1.73. So for our CFS, I can change to by 1.73. So next time if I use the CFS, it will be used to break diameter. CWSR, we haven't used it, so we ignore it at the moment. And the true OT at the top is 1.69. Will be used for radial friction correction, only on that one. So the rest is not used. So if you don't have any TBDC or not TBDC, the gradient, because TBDC doesn't have the tool, so it's only back friction. If you deal with the gradient tool, this one will be used. But for the other tools, I mean, this is not really being used. Tool offset here, tool deficit and offset. So you might click on that one while we are in the tool information. So you might see there are two columns, deficit 1, deficit offset 2. So number 1 is for passes and station, the second one of station. Why we need to put the depth offset for station? No, we haven't done station, but just want to know why we need to put depth offset for station.
If it's wrong depth.
If it is not wrong there,
The offset for every sensor.
yes,
But is it supposed to be calculated?
automatic.
Yeah.
That's the past data.
Okay.
When we put the station, we just put one depth. So the depth of the bottom of the tool. And the sensor you have some offset. So if we deal with quite long interval, doesn't matter. It's just 1 or 2 meter, 3 meter difference. But if you deal with the small layers, maybe your CFS in the below the layer, ILS is above that layer, so it's not reading the correct. I mean the same condition.
Okay.
So in the small thin layering, yes, you might need to put the correct offset. So you look at your tool string diagram, just put in the numbers.
Okay.
Yeah. So that's on the second column on the offset for the station. But yeah, it really depends on the cases. So if you deal with the long interval, then you don't really care about this. If you deal with the small layers, a lot of different small layers, and then yes, this one is it's quite important to set the station offset.
So this is only for station.
It is, yeah,
Not-
you can see
or
the
not,
station only.
not for up and down passes.
Up and down is already correct.
Okay.
Yeah. Because when you receive the data, value it for you.
Yeah.
Yeah. So if it is not, we can do as well. If it is not.
Okay.
So yeah, you can do this one, the depth sheet. This is for if it is not corrected. For example, in the actual tool string, you have, for example, CCL gamma ray. But when you defining in the value gamma ray CCL,
Okay.
so both are not correct. So then in the case you import into Emerald, you make the correct offset.
Okay.
So the gamma ray should be at the bottom, CCL should be at the top, so you just correct, the distance between those two.
With this option.
Yes, in the first column.
Oh, the first column. Oh,
First column will
okay.
be applied on the pass and station.
Okay.
If only the station, that's on the second column.
Okay.
Yeah, because be careful with the setting in the warrior. If it is not really the same as the physical connection,
Yes.
be careful. Yeah, one time we did in Total Balikpapan, we have a campaign 10 PLTs. So most of them are not correct. So when you do the gamma ray, depth matching, the CCL is off.
Oh.
When you do CCL, gamma ray is off. Oh, so it's very difficult because in Pachico, they have very small thin layers, 1 or 2 meters, but there are 40 layers in one well, 40 perforation. So then you have to be very delicate, very detailed on the depths. And then finally, we told the total, and then total tell the service company. So yes, they have some problem with that thing. CCL, Kamare, CCL, they switch things like that. So they rerun the tool. Yeah. So yeah, it's sometimes you can see this one, but sometimes you don't see. Okay, so that's the tool shift to offset and the spinner plate diameter. So remember, the plate diameter is not the tool diameter, it's the plate end to end. Yeah, it's diameter of the plate. Usually it's coming from manufacturer, so it should be okay. Especially if you deal with this full ball, you have different sizes. So yeah, I can go on that one. But the change is not that much, but at least you make it correct at the first time. Okay, so yeah, the ILS is 1.2. So we go to the next app, we did that one. So we go to PVT. So what PVT we have here? We have PVT. Let's see. Okay, so we have a file EPV, but we just use this one. Salinity 500 SG S.7. You see, the salinity is very fresh. So it's just condensed water. It's not the formation water produced. So it's just condensed water because when you are decreasing the temperature pressure, you might have some water out of gas. So 0.7. So just put the dry gas and click on the red bottle, and okay, it's 0.7 is the default. So you don't need to change.
0.7.
Yeah, if you have CO2 component and 2 component, you might be adding on that one as well. So you don't change anything, it's just the default, yeah. So if I just make the PVT as a single phase, then on the rates will be only single phase option. So it's depend on the PVT definition. So first I just used one dry gas, and then what I do next is QCalc zone. So if I click QCalc zone, there are 3 options. So the first option, top of perforated intervals, maybe how many meter above this, how many meter. And then you can have a same spinner calibration. I cannot do that, but because in the middle between perf, I don't have yellow. So if I have yellow in between perfo, I can put the gray zone, calculated zone, similar with the yellow zones. Usually I just use one tray. So I have my flexibility to choose the interval of the gray zone. And I have a lot of track to see, but I like to see only the necessary curves. So I just update plot layout as a default, and then I click OK. So I will see only reference channel and velocity max.
Can you repeat the PVT again?
Sure. PVT.
Yeah.
So I click on the dry gas.
Okay, dry gas.
And then I go to the red portal.
Red bottle.
Red portal, I don't change anything because the 0.7 is the one that we need to put in. If you have CO2, you can touch type in if you want.
Okay.
But yeah, just 0.7, make it simple. And I click OK. Yeah.
Okay.
Remember, the bottom one is for the temperature. Yeah, the heat capacity quantity of this gas. So that's the PVT only. So single phase in the PVT, then we go to this QCalc zone. Why? Because in the info, remember in the main, we just put zone. Zone approach. In the info, first page, zone approach. So we'll be doing by the zone. That's why I need to put QCalc zone. So if I click on that one, okay, I did the same things on the one and this one we did already. So if I click on that and back here, then it waits for us to define where the gray zone will be located. So I need to have pressure temperature good and 0 on that one. So probably I need to put something like here, and probably more 0. This is the gray zone. And then I like to put the second gray zone. I need to click on this. I put the second one maybe here, and I put the third one at the bottom, somewhere. Just put maybe 0 around here. So something like that. And in between the grays, automatically set the blue according to red. So the gray has to be at the stable VR, and you have a good pressure temperature, because we'll be taking the average pressure temperature and this interval and the velocity of the interval to calculate the Q of gas. Okay, so we define this one. And then what we need to do, the next step, Q calc zones, rates, click on this one. Because we define PVT as a single phase dry gas. So flow model will be only single phase. So if I click OK, it will go to the second tab. Yeah, we have only one variable to match, velocity in line. So you can see measurement here is the red curve. The calculated is the model. So we try to make the model in order to have very small error or very small difference between model and data, or in this case is velocity error. So you do it for the top one, the second one, and the third one. So it automatically will do it for minimize the error. Error percentage is just between calculated minus measured and 100%. So that's the ratio. And if you look at the VPGF at the bottom, is 0.5. Is it laminar? Maybe not. Why? Because the velocity is very small, so we ignore the VPGF. So if you go to the second one, which has a quite high number of velocity, VPGF is 0.877. Yeah. So this is okay. Question?
What number is it okay or
0.75 and the 0.98.
Oh, that's okay.
Yeah.
The blue zones never appear for me.
Okay. So
The Q calc.
okay. We have operation is red.
Mm.
Yeah. So we take the Q calc, the gray should be not at birth.
Okay.
Yeah. So it's above or below at the stable condition, stable rate, stable velocity. So I put that one at the top. Then I put the second one below the top. Birth.
Just click, right?
Hmm?
Just click, right? The
Click,
that-
yeah, click and drag and just make it, yeah.
Ah,
Click and drag
okay.
because it's interval. Click, hold, drag.
Okay, wait.
Yeah. So after that, then automatically we'll make a blue equal to the red. Because emerald will assume that inflow will be happening in front of the perforation. So the blue is in inflow zones. So the inflow zone will be the same as the red perforation. Okay. Yeah, we need to, if you want to delete, just click and delete, or, okay, let me click OK first. And then I click OK again. I have something like this. So if you want to delete, just click on this one and delete. Right click, I guess. Right click, delete. Right click, delete. Or you can go to edit. You go to edit, click up, delete. Yeah. You can refine or refine again. Change the interval or replace with other intervals. You can just type in the value, or you want to delete, you can just delete. So either way. interactively by mouse or just put numbers. It doesn't have to be the same, it's just take some values on this.
I'm still not getting the inflow zones.
You don't have inflow zone?
No. Kita we can.
Okay.
Ni tak boleh.
Tak payah. Klik.
Okay. Okay.
And then you go.
Atas. Okay.
Right.
Okay.
Okay.
Select. Yes.
Just long press.
Yes. Long press macam buat zone spinner
Yeah, tekan, hold and drag.
Sampai sini.
panjang sangat. Dalam 10 meters macam tu. Yang grey box tu.
Ini kan?
Okay. Buat another one.
Yeah, click again, Q count.
Better jangan masuk yang puff area.
So I edit back.
Ni boleh drag je kat sini. Right.
Oh, boleh.
Click and then drag je. Okay. And then make another one. Bawah puff. Sikit. Alright. Flow zone ada.
Okay.
Dia in between. Buat another one. Bawah pada zone. Nanti in between ada inflow zone. Okay.
Okay.
Okay. What was the problem?
I don't know how to drag.
Yeah, you're right. You can type in the value, but it's always easier user. So yeah, you have the blue now, right? You have the blues. Then you go, I think just go back to reds and I add this one. So at the top, this is no flow zone. So whatever the value here is very, very small. So if you want to force to 0, I can just click no flow. So we'll force to 0 because I know it's no flow. On the second one, I have very small error, which is okay because I have my model close to the red or the VF spinner. And my VPGF is this number. And again, this is based on mu and Reynolds numbers based on the area, density and mu, density mu at PMT. So you can go to parameters, click on the next tab. You have this one, mu and density at PMT. Yeah, at PMT you have this one, which is coming from the correlation and SG gravity specific is equal to 0.7. And depending on the correlation, then we come up with these three values. This one will be used for the VPGF in the second zone. Remember, the zone now is gray. Yeah? It's gray zones. So the middle calculation zone, we use that one to get the VPGF, the value here. So that's okay. And you might see the VM velocity mixture. Remember, the velocity of spinner is this one, 120 negative. But actually, the VM velocity of your mixture is 105. VM, this one, times VPGF is equal VM.
Okay.
Yeah. Remember yesterday? This one here. VM, VPGF times VM. So VM usually is less than VM. Yeah, so the second one is okay. And the third one, we know it is water and it's no flow, so I can force again no flow. And if you want to look at the parameters, then you can go to the third tab and look the numbers. Does it make sense or not? Because sometimes the pressure temperature may be not correct the unit, and of course this PVT parameters is not the correct value we use. And yeah, just make sure the numbers there. Remember, roughness is for DBDC because we don't use DBDC, so it's not using just single phase, so there is no. Yeah, we still have friction, but we don't use the DBDC for calculation. We just use the spinner just to make it very simple. So we are not comparing, or we have no density match. We have the velocity match. So we might do this one in the flowing with the density match.
But when I've pressed
Yes.
the bottom one, no flow, and then error 100%,
Tak apa, tak ada nol.
run null. It's
Yeah,
okay.
nol, I mean, minus 0.28 something is 100%
Yeah.
error.
Mm.
So no problem.
Okay.
If we force it, usually it's close to 100%
Oh,
because we force it, right?
okay.
So it's not regression.
Mm.
Yeah.
I thought we cannot leave it 100% error or any error. But it's okay to leave.
No, it's okay because we force it because we have small number, right?
Oh,
Zero,
okay.
zero something,
Mm.
and we put zero. So
Mm.
zero minus very
Just
one number
Mm.
is very different, right? So it's
Mm.
100% error.
Okay.
So it doesn't know.
We can ignore lah.
Yeah, ignore that.
Oh.
Or if you want, just leave this like this.
Mm.
But then again, you might have very small number at the bottom.
Mm.
So it's up to you. But if you want, I mean, if you really want to have zero, just force it. If you're okay with this small
This one,
number, that's fine.
together with this. His velocity match graph is missing.
Velocity match. The scale. Oh.
Pressure.
The top one. Vector. Bottom one you haven't changed. Okay, anyway, so with this one. See, from 2, you need to reset. You have dots. You are on the settings. I think on the match. Maybe not. Maybe on the setting. You were doing when you changed the match view. So station you don't change anything. It's okay. The match view. The match view version. We go to view, match view. I don't know why you have some dots here. You should be just line. That should be the settings here. You can go to match. This is match view. Straight line. Anyway, so as long as you have this value, right? And then you might just go to range and just click OK. Okay, you have it. Oh, because you changed the to your piezo petro. Because it's yellow. Yeah. Oh, you don't need to have. You have another one here, so you should have two only, not three. Yeah, something like this. So yeah, he changed the color forecast to be yellow. It's okay. So yeah, we see this one, and then what we can do now, you can see that the red and green, they are not really aligned. So I can adjust the blue according to the red. So I can click on the blue one, I can adjust a bit here, moving up a bit, and that one maybe I move down a bit. So I'm adjusting. So it's not the total interval of producing. Yeah, something like that. And after that, I will just do logs again, click OK. So we'll redo. So you refine the model based on your spinner response. Okay,
Tak cantik.
reset. So you can refine the inflow zone, or you might maybe more than one inflow zone according to the response that you might be able to. And you see this one is at the bottom called the whole condition. Some of the client they like to be at standard condition. So what we should do, in the logs, there is standard condition option. So we click on that one. Then I click OK again. Nothing changed. Because I like to go right click, show at standard condition. So you'll be having SG, standard condition. And we'll change the unit into the standard condition unit.
Right click and
Standard condition. Below play.
Right click dekat QZ.
show surface rate.
No, at
Right.
standard condition.
Tak ada.
Right click dekat QZT.
Okay.
Do you have it? No, because you haven't calculated. So you need to go to logs first
Okay.
and tick on the at standard condition. You need to tick on the bottom left
Okay.
and then click OK.
Okay.
And then you can right click and you have this option at standard condition.
External condition.
No?
Okay, now I have it.
Yeah, because you need to calculate first and then you can show.
But
Yeah,
it means that it only change million scarf per day and then barrel per day? Or
no, it will be depending on the BG,
okay.
volume factor.
Uh-huh.
So change because the unit is different. You can click on the info here.
Okay.
Oh, sorry. Where do I have? It is info here at the top.
Uh-huh.
You have document unit.
Okay.
You have the downhole rate unit,
Okay.
which is the downhole rate unit we have. And we have the gas rate surface unit.
Okay.
So that's the unit that we use.
Okay.
It's not just converting the unit,
Okay.
it's converting the condition.
Okay.
PNT.
Okay.
Protocol PT, standard condition PT.
Mm.
So it's not just a unit conversion.
Okay.
Yeah. So if you deal with the gas, you might want to have the bottom one not grade BD,
Mm-hmm.
but maybe MSC per day, for example.
Mm-hmm.
Just that is up to you. Or depend on the client, they like it. So just to show, you might be able to show it in standard surface condition. Yeah. So one more thing, I can do in the logs. There is a complete logs. So I can click compute at sample interval, this one. So if I click OK, I have something like this. This one is coming from the red curve here, VII less. The set T set I is from VILS So the green line here. But the Q is from the red line. So you can see a bit changing here noise because of this red. So more or less this and that should be similar. Okay, so that's for example, I like to have this one as a snapshot, and I can put this snapshot to the report. I can save the snapshot